Bismillah ar-Rahman ar-Rahim. Alhamdulillah wa salatu wa salam ala Rasulillah. These are some review exercises about chapter 3, which is about derivatives. So here calculate y prime, and let us use all the rules in this section, in this chapter, to find the derivatives here. So here we use the chain rule. 4 times x squared plus x to the power 3 all to the power 3 times the derivative of what is inside. So derivative of x squared is 2x plus 3x squared. Here I will first rewrite y. 1 over square root of x, I will write it x to the power negative half. And this is x to the power 3 over 5. And when I take it up, it would be x to the power negative 3 over 5. And now I can find y prime. It is negative half x to the power negative half minus 1, and this is negative 3 over 2. And negative 3 over 5 times minus, so it would be positive 3 over 5 x to the power negative 3 over 5 minus 1, which is negative 8 over 5. And to get rid of the negative powers, you can rewrite it again as negative 1 over 2 x to the power 3 over 2 and plus 3 over 5 x to the power 8 over 5. Here I need to distribute first the numerator over the denominator. So y would be x squared over square root of x, and when I subtract the powers, 2 minus half is 3 over 2. Then minus x over square root of x, 1 minus half is half. And plus 2 over square root of x, which is 2 times x to the power. When I take it up, it would be to the power negative half. And now I can find y prime. It would be 3 over 2 x to the power 3 over 2 minus 1 minus half x to the power half minus 1 minus half times 2, that's minus 1, x to the power negative half minus 1. And if I want to get rid of all the negative powers, there is no negative power in the first term. In the second term, I can take x to the power half below, and in the last term, I take x to the power 3 over 2 below. Here I use the quotient rule. So 1 plus cosine x all square. And then the derivative of tan x is secant square x. Of course, you have to study the chapter well before you solve these exercises, because everything depends on the formulas we studied in the chapter. Minus tan x, the numerator, times the derivative of the denominator. Derivative of 1 is 0. Derivative of cosine is negative sine x. So that is the answer. Okay, it's okay to simplify. Now secant square times 1 is secant square, and secant square times cosine. Secant times cosine is 1. So I'll have plus secant. Okay, secant times cosine is 1, and still 1 secant. So I have secant x, then minus times minus is plus, and sine x times tan x. 1 plus cosine x all square. Okay, this is enough for me. I can simplify more, but I think that this is okay. Now here I need to use the product rule. So the derivative of x squared is 2x times sine pi x, then plus x squared, times the derivative of sine, which is cosine pi x times the derivative of pi x, which is pi. Now here again it's product, and the derivative of x is 1 plus x times the derivative of cosine inverse. Well, derivative of cosine inverse is -1, and this is the x outside, over square root of 1 minus x squared. That's the derivative of cosine inverse. It is similar to sine inverse, only with a negative sign. Here I will use the quotient rule. So t to the power 4 plus 1 all square. Derivative of the numerator is 4t cube times the denominator minus derivative of the denominator, which is 4t cube times t to the power 4 minus 1. Now I can see that 4t to the power 7 will be cancelled with negative 4t to the power 7, while 4t cube will be added, because this is minus times minus will be plus, will be added with 4t cube. So we will have 8t cube, or t to the power 3 over t to the power 4 plus 1 square. If you want, please expand and you will find this result. Well, here it's obvious that it's an implicit differentiation, because why? The equation is not written explicitly like this for y. It's not solved for y explicitly. So we use implicit differentiation. So here we have product. So the derivative of x is 1 times ey plus x times the derivative of ey, which is e to the power y times y prime, or dy by dx. And also here we have product, derivative of y is y prime times sine x, and then y times derivative of sine, which is cosine x. And to find y prime, I write the terms with y prime, I collect them in one side, and the other terms in the other side. E to the power x was there, so when I bring it, it would be negative e to the power x. And now you take y prime as a common factor. And then we divide, and we get y prime. X ey minus sine x. Here we have a composition. So we use quotient, we use chain rule. Derivative of y, derivative of len first, derivative of the outer function, which is len. Derivative of len is 1 over x times len x. Now times the derivative of x len x. And this is product. So derivative of x is 1, and x times derivative of len x, which is 1 over x. So the final answer would be x times 1 over x is 1. I can take it here, I can write it first. 1 plus ln x over x ln x would be the final answer. Here I have product. Derivative of e to the power mx is e to the power mx times m plus e to the power mx times the derivative of cosine, which is negative sign. That's why I left this negative. Negative sine nx times the derivative of nx, which is n. This is product. Derivative of square root of x is 1 over 2 square root of x times the second function, which is cosine square root of x plus square root of x times the derivative of cosine, which is negative sine square root of x times 1 over 2 square root of x. So the final answer would be cosine square root of x over 2 square root of x minus sine square root of x over 2. This is chain rule. Y prime is 2 times sine inverse 2x to the power 1 times the derivative of sine inverse, which is 1 over square root of 1 minus u square, 2x square would be 4x square, times the derivative of 2x, which is 2. Here I have quotient. So this would be x to the power 4. Derivative of the numerator is e to the power 1 over x times the derivative of 1 over x, which is negative 1 over x square. So this is the derivative of the numerator times the denominator, which is x square. Then minus 2x, the derivative of the denominator, times e to the power 1 over x. Well, this x square cancels with this x square. So I have negative e to the power 1 over x minus 2x e to the power 1 over x to the power 4. You can take e to the power 1 over x common factor if you like, or you can leave it like this. Now, this is composition. Derivative of the outer function, which is ln, is 1 over times the derivative of secant, which is secant tan. Secant cancels with secant, and the derivative would be tan x. Here it is an implicit differentiation. Derivative of y is y prime. This is a product. Derivative of x is 1 times cosine y. Now derivative of cosine y is negative sine y times y prime. This is also product rule, 2x times y plus x squared times y prime. Now I have 3 terms with y prime. So bring them to the left-hand side and take y prime as a common factor. So 1 from here, negative x sine y from the second term, and negative x squared from the last term. And here I will have 2xy. Take this term to the other side, minus cosine y. And then y prime would be 2xy minus cosine y over the coefficient of y prime. Well, I can use the power rule here, and I can use also the logarithmic differentiation. All right. Let me use the usual formula. Y prime would be 4 times u minus 1 over u square plus u plus 1 to the power 3. This is the chain rule times the derivative of what is inside. So this is u square plus u plus 1 to the power 2, the quotient rule now. Derivative of the numerator is 1 times u square plus u plus 1 minus derivative of the denominator is 2u plus 1 times u minus 1. And you need just to expand this one and find the answer. So it is u square plus u plus 1 minus. Here I have 2u square plus u minus 2u, so that's minus u minus 1. So I will have minus 2u square plus u plus 1. So it would be 4 times u minus 1 u square plus u plus 1, and here I have u square plus u plus 1 to the power 3, and here I have negative u square plus 2u plus 2. Well, I use the quotient rule. Derivative of square root is 1 over 2 times the square root times the derivative of tan inverse. Well, derivative of tan inverse is 1 over 1 plus x squared. This is also chain rule composition. Derivative of cotan is negative cosecant square times derivative of cosecant, which is negative cosecant cotan. So this would be the answer. Only the minus you can multiply with the minus and make it positive, but the other functions remains the same. Well, the derivative of b to the power x, b to the power u, is b to the power u times ln 3 ln b times the derivative of u, which is x ln x. This is a product. Derivative of x is ln x is 1 times ln x plus x times the derivative of ln x, which is 1 over x. So x times 1 over x is just 1. So that's the answer. This is an implicit differentiation. Derivative of sine is cosine times now the derivative of x times y, which is a product. Derivative of x is 1 plus derivative of y is y prime. 2x minus y prime. Well, I have xy prime times cosine xy plus y prime in one side, and I have 2x minus y times cosine xy in the other side, and then I can take y prime as a common factor, and I divide 2x minus cosine xy over x cosine xy plus 1 when I take y prime as a common factor from the left-hand side. This is log, and the derivative of log u to the base b is 1 over 1 plus 2x, okay, times ln 5 times the derivative of 1 plus 2x, which is 2. Now here, function to function, I have to use logarithmic differentiation. So I apply ln to both sides. And this would be x ln cosine x. I can take x here in front of ln. And now I find the derivative. Derivative of ln y is y prime over y. And here I have product. Derivative of x is 1 plus x times derivative of ln cosine, which is 1 over cosine, times derivative of sine, which is sine. So y prime would be ln cosine x plus x times sine over cosine. I can write it tan x, and I'll multiply all of this by y, and y is cosine x to the power x. So this is the derivative. Here also I will use logarithmic differentiation. So ln y would be equal to, if I apply ln to the right hand side, then I can simplify and write it ln x squared plus 1 to the power 4 minus ln 2x plus 1 to the power 3 times 3x minus 1 to the power 5. And then ln y would be equal to, I can take the 4 out. And here, this is ln product, so I will change it to addition. And the 3, I can take it out, so it would be 3 ln 2x plus 1. And now plus, but there is a minus sign outside, so it would be a minus, and this 5 will come here. And now I simplified the equation, and I can start deriving. Derivative of ln y is y prime over y. Derivative of this is 1 over x squared plus 1 times 2x, and there is a 4, so times 8x. Derivative of ln 2x plus 1, 1 over 2x plus 1 times 2, and there is a 3, so 6. 1 over 3x minus 1 times 3, and there is a 5, so it would be 15. And finally, I write y prime equals all of this times y, and y is x squared plus 1 to the power 4 over this times this. We studied that the derivative of ln absolute value of u is 1 over u. So times u prime. So u prime would be 1 over secant 5x plus tan 5x, and there is no need for the absolute value. This is what we studied. Times the derivative of secant 5x. Secant 5x derivative is secant 5x tan 5x times 5, the derivative of 5x, plus derivative of tan is secant square 5x times the derivative of 5x, which is 5. And I can stop here. Let me think. If I take 5 secant x as a common factor, yeah, I can. Let me take 5 secant, this is 5. Five secant 5x, let me take it as a common factor. So I will have tan 5x plus, I take 5 secant 5x, so I'll still have secant 5x over secant 5x plus tan 5x, and these two can cancel. And the final answer would be 5 secant 5x. That's a very nice answer. we just solve the question like this. Y prime is 10 to the power tan pi theta times ln 10 times the derivative of tan pi theta, which is secant square pi theta times derivative of pi theta, which is pi square root. So y prime is 1 over 2 times the square root, and inside the square root I have product. So derivative of t is 1 plus t times the derivative of ln t to the power 4, which is 1 over t to the power 4 times 4t to the power 3. And t3 times t would be t to the power 4, so they will cancel with each other. This with this with this. And I have 4 plus ln t to the power 4 over 2 times the square root of t ln t to the power 4. Derivative of sine inverse is 1 over square root of 1 minus u square, which is this time cosine square theta, times derivative of cosine, which is negative sine theta. Well, 1 minus cosine square is sine square. And square root of sine square is absolute value of sine. And absolute value of sine could be positive or negative. But theta is between 0 to pi. This is in the first and the second quadrant. And in the first and the second quadrant, sine is positive. So I will have negative sine theta over sine theta, because sine theta is positive and the answer is negative 1. That's nice. Derivative of ln 1 over sine inverse x squared times the derivative of sine inverse x squared, which is 1 over square root of 1 minus x squared to the power 2. So it would be x to the power 4 times the derivative of x squared, which is 2x. Implicit differentiation y prime plus derivative of ln y is y prime over y. Product derivative of x is 1 plus x times derivative of y squared, which is 2y y prime. Let me multiply by y to get rid of the denominator. So I have y prime plus y prime equals y3 plus 2x y squared y prime. And then y prime plus y prime minus 2x y squared y prime equals to y cube. And then you take y prime as a common factor and you divide by y cube by y plus 1 minus 2x y squared. So that's the derivative. I have product here. So y prime derivative of x is 1 hyperbolic sine of x squared plus x times derivative of sinh is cosh x squared times 2x derivative of x squared. So there will be 2 here and another x here, 2x squared. Sine square, this is the outer function. I have composition. So y prime would be 2 times sine of all of this. okay, times derivative of sine, which is cosine all of this. Okay, this is the derivative of sine. Now, derivative of cosine is negative sine all of this. Okay, so this is product. This is the derivative of cosine. Now, derivative of the square root. Derivative of the square root will be 1 over 2 square root of sine pi x times the derivative of what is inside the square root. Derivative of sine is cosine pi x times derivative of pi x, which is pi. So this was many chain rule. Chain rule used many times. Okay, find f double prime of 2. Let me find first f prime of t. This is the square root, derivative of 2 times 4t plus 1 times derivative of 4t plus 1, which is 4. Now I can cancel this with this. I have 2 here. Now if double prime of t, I have to use I don't want to use the quotient rule. So derivative of 2 is just a number, so leave it. Now what is the derivative of 1 over x? 1 over u. It is negative 1 over u square when you square the square root times the derivative of the denominator, which is the square root. Derivative of square root of 4t plus 1 is 1 over 2 square root of 4t plus 1 times derivative of 4t plus 1, which is 4. And again, 4 cancels with 2, and I have 2 here. So you can say that it is negative 4 over 4t plus 1 to the power 3 over 2. And now if double prime of 2 would be negative 4 over 2 times 4, 8 plus 1, 9 to the power 3 over 2, that's 27. Find y double prime. This is implicit differentiation. So let us first find the first derivative, 6x to the power 5 plus 6y to the power 5 times y prime equals 0. And now to find y double prime, let me solve this equation for y prime. So y prime would be equal to negative 6x to the power 5 over 6y to the power 5. And I can cancel 6 with 6. Now y double prime would be y to the power 5 raised to the power 2. 2 times 5 is 10. Now derivative of x to the power 5 is 5x to the power 4 times y to the power 5, the denominator. Notice this minus outside, so minus times minus would be plus. X to the power 5, which is the numerator, times the derivative of y to the power 5, which is 5, y to the power 4, y prime. Okay. Notice that I can take y to the power 4 as a common factor. So I will have negative 5x to the power 4 times y plus 5x to the power 5 y prime over y to the power 10. And I can cancel this with this, and I'll have 6 here. Okay. If you want, I can write it negative 5 x to the power 4 over, I have y to the power 6 and y up, so y to the power 5, and plus 5 x 5 y prime over y to the power 6. Okay, so I'll stop here. I can make many different ways of this, but I'll stop here. This is y double prime. Find an equation of the tangent line to the curve at the given point. So this is the curve and this is the given point. So the equation of the tangent line is y minus 1 equals the slope times x minus pi over 6. And the slope here is y prime at pi over 6, which is x. So I need to find y prime. So y prime is, the 4 is just a coefficient. The derivative of sine square is 2 sine x times the derivative of sine, which is cosine. So now y prime of pi over 6 would be 8 sine pi over 6 times cosine pi over 6. And sine pi over 6 is 1 over 2. And cosine pi over 6 is square root of 3 over 2. So this would be 8 over 4, 2 square root of 3. So the equation is y minus 1 equals 2 square root of 3 times x minus pi over 6. Find an equation of the tangent line. Well, it is y plus 1 equals m times x minus 0, or just x, where m is y prime at 0. So let us find y prime, use the quotient rule, x squared plus 1 to the power 2. Derivative of the numerator is 2x. Derivative of the denominator is 2x. Well, I can simplify y prime, but I just need y prime at 0, so I'll do it quickly. If I put x 0, then 2 times 0 is 0. 0 times this would be 0. 2 times 0, 0. 0 times this would be 0. Here 0 plus 1 is 1. So I'll have 0 over 1. So that's just 0. So the equation is y plus 1 equals to 0. Or y equals negative 1. If you simplify this, you notice that you have 2x cubed and here minus 2x cubed. They will cancel each other. And you will have 2x plus 2x. So actually y prime after simplifying is 4x. Okay, if you want to simplify first. And now when you replace x by 0, you see that y prime is 0. Find the equation of the tangent line and normal line to the curve at the given point. So the equation of the tangent line is y minus 1 equals m times x minus 2, where m is y prime at 2. So here I have implicit differentiation. Derivative of x squared is 2x. This is product 4x, or derivative of 4x is 4 times y plus 4x times derivative of y, that's y prime, plus 2y y prime equals to 0. Now to find y prime, I need to replace x by 2 and y by 1 because I have x and y here. So if x is 2, I have 4 plus y is 1, so this is another 4, plus x is 2, so 2 times 4, that's 8y prime. Y is 1, so that's 2y prime equals to 0. 8y prime plus 2y prime, that's 10y prime. 4 plus 8, 4 is 8. Take it to the other side. So y squared is negative 8 over 10 or negative 4 over 5. So the equation of the tangent line is y minus 1 equals negative 4 over 5 times x minus 2. This is the equation of the tangent line. Well, for the normal line, we know that the normal line is perpendicular on with the tangent line. So the slope, they all pass by this point. So I have the same equation, but the slope is different. The slope of the normal line is the reciprocal of the slope of the tangent line. This is 4 over 5. This would be 5 over 4 multiplied by a minus sign. So 5 over 4. Now, if you multiply the two slopes, you get negative 1 because the two lines are perpendicular. So this is the equation of the normal line. Again here, same question. Y minus 2 equals m times x minus 0, and m is y prime at 0. Well, y prime, I have product. Derivative of 2 plus x is 1, because derivative of 2 is 0, times e to the power negative x plus 2 plus x times derivative of e to the power negative x, which is e to the power negative x times minus 1. That's why I left this minus. So this is y prime. So y prime at 0 would be e to the power 0 is 1, minus 2 plus 0 is 2. E to the power 0 is 1. So 1 minus 2, that's negative 1. So y minus 2 equals negative x. This is the equation of the tangent line. Well, for the normal line, if the slope is negative 1, when you find the reciprocal, it's also negative 1 multiplied by a minus, it would be 1. So the slope of the normal line is just y minus 2 equals x. If you want to write this negative x plus 2 and this one x plus 2, it's okay. At what point on the curve, on this curve, is the tangent horizontal? Well, the tangent would be horizontal if the slope is 0. So he is asking about the point on which the derivative is 0. So let us find y prime. So y prime would be 2 using the chain rule times ln x plus 4 times the derivative of ln x plus 4, which is 1 over x plus 4. So that's y prime, and we need it to be 0. We need the point at which the derivative is 0. Tangent is horizontal. Now, if you multiply cross product, okay, then 2 ln x plus 4 would be equal to 0, or ln x plus 4 is 0 if I divide by 2. And raising both sides to the base e, I will have x plus 4 equals e to the power 0, which is 1. So x is 1 minus 4, which is negative 3. And if x is negative 3, I need the point. So how to find y? So I have y, so I'll replace x by negative 3. So y would be ln negative 3 plus 4 is 1, and ln 1 is 0, so 0 square is 0. So the point is negative 3 and 0. The volume of a right circular cone. Right circular cone, yeah, this is the volume of the right circular cone, where r is the radius of the base and h is the height. All right. Find the rate of change of the volume. So with respect to the height, with respect to the height. So he's asking about dv by dh. Find the rate of change of the volume with respect to the height if the radius is constant. So the radius here is a constant function. So let us find dv by dh. Okay, so 1 over 3 is a constant, pi is a constant, r squared is a constant, and derivative of h is just 1. So that's the answer, 1 over 3 pi r squared. Find the rate of change of the volume with respect to the radius. So he needs dv by dr if the height is constant. So dv by dr would be, now 1 over 3 pi h are constants. And I need to find the derivative of r squared because we are finding the derivative with respect to r. This is similar to dy by dx, okay? So derivative of r squared is just 2r. So the final answer is 2 over 3 pi hr. This would be dv by dr if the height is constant. The volume of a cube is increasing. Okay, let me call it v. So dv by dt is 10 centimeter cube per minute. How fast is the surface area? So let me call the surface area S. So ds by dt is required when the length of an edge, let me call the length of the edge x. So when x is 30. So that's what we need to find. Well, I need a formula for the surface area. You know, the cube, if I ask you how many faces the cube have, okay, how many faces? If you count the faces of the cube, 2, 4, 6, there are 6 faces. And if the length of an edge is x, then the area of each face is x squared. And I have 6 faces. So the surface area is actually 6 times x squared. This is the formula for the surface area. So to find ds by dt, it is 2 times 6, 12, x times dx by dt. Well, I have x, it is 30, but I do not have dx by dt. How can I find dx by dt? I need to use this information. He said that the volume dv by dt is 10. So is there a relation between, what is the volume? Well, the volume of the cube is x cube, x times x times x. So dv by dt would be equal to 3x squared times dx by dt. Oh, so dx by dt is here. Well, I have dv by dt, which is 10. And I have x, which is 30. So I can solve this equation and find dx by dt. So dx by dt would be 10 over 3 times 30 square. Okay. This is dx by dt, which is 1 over 270. So now I can go back to this equation and find ds by dt when x is 30. And this is the required. This is what he asked for. It is 12 times x, which is 30, times dx by dt, which is 1 over 270. So 12 times 30 over 270, that's 4 over 3. So 4 over 3, and this is the surface area, so it's centimeter square per minute. This is the rate of change of the surface area. The last question, a paper cup has the shape of a cone, so circular cone like this. Okay, this is the cup. with height 10. So this height is 10 centimeter, okay? And the radius of the cup is 3 centimeter, and these are not changing. If water is poured into the cup at a rate of 2 centimeter cube per s, so the volume of the water inside the cup is increasing by 2 centimeter cube per second. So the water, for example, reached somewhere here, okay? This is the water. This is the height of the water, and this is the radius of the water. Well, how fast is the water level rising? So he's asking about dH by dt, this h. When the water is 5 centimeter deep, so when the height is 5 centimeter, that's the question. Well, I need to find a relation. I know that the volume is 1 over 3 pi r square, the volume of the cone, h. Now, I need to find the derivative with respect to t, but I have three variables, v, r, and h, and they are changing. The volume of the water, the radius of the water, the height of the water, all of them are changing. So I want to write one of them, h and r. Now I need dH by dt. So r is not needed here. So it would be fine if I write r in terms of h. So I need to find the relation between r and h. Now I need to compare these two triangles, the green one and this one, the purple one. These two triangles are similar triangles. So the radius here over the radius here is equal to the height of the green triangle, which is 10 over h. I need to write r in terms of h. So hr would be 10r would be 3h, or r is 3 over 10 times h. So I can write this equation as 1 over 3 pi times, and r square, I can write it 9 over 100 h square times h. So the volume would be 3 cancels with 9. So I have 3 pi over 100 h square times h is h cube. And now I have v and h only, so I can find the derivative of this equation with respect to t. 3 pi over 100 is just a constant. The derivative of h cube is 3h square dh by dt. And now dv by dt is 2. 3 times 3 is 9. I can write this 9. H square, h is 5 as given. So 5 square, h square is 25. And I need to find dh by dt. 25 by 100 is 4, 100 by 25. So dh by dt would be equal to 8. 4 times 2 is 8 over 9 pi. So 8 over 9 pi centimeter per second. This is the rate of change of the height of the water. Thank you very much. I hope you enjoyed this review about chapter 3.